Mod- Module 6, Man BMW Camshaftless Engine, MEC engine. In this, we'll talk about COCOS, EDS, and PMI. Basically, performance, how we take, that we will discuss, we'll talk about, and the adjustment, the very important part of your running the engine. Computer control, computer surveillance is the EDS, engine diagnosis system. That is the meaning of COCOS, EDS. All right. COCOS, EDS, and PMI module 6.0. If you see, remember first module, introduction, about the basic version and the full version I had told you. Basic version is all ME engines. Full version is of course optional. Owner has to pay for it. COCOS EDS stand for computer controlled surveillance. Computer controlled computer surveillance. Engine diagnosis system. Diagnostic system. COCOS EDS comes with 4 primary engine surveillance tasks. All the 4 tasks are always available to the user. Data logging, monitoring, diagnostic, and trend logging. So in this module, we'll primarily talk about monitoring. Because this we had talked about earlier also. Monitoring we'll be talking about. Basic version. Basic version is installed on all ship with ME engine. Full version installation is done by the service engineer. It cannot be done by the ship staff. In basic version, bearing wear monitoring and liner wear monitoring, etc. is not available. Basically, with that, you can also, if you have your full version, you can do the condition monitoring of the engine also and carry out the maintenance accordingly. Up to 30,000 hours engine has been done. 30,000. So this is the arrangement basically. Your ship, engine, your MPCs, your PMA controller cable. Because this is basic version, this is not there. Bearing monitoring and liner bearing monitoring is not there. All right. MOP and NOPB, Ethernet connection, as I told you earlier, also known MOPB. This is your COCOS and PMI, separate computer. And this is your AMS. Now this data, if AMS will be there on the advanced version. Of course, this with the through the firewall, VPN router, this will go to your computer on your control room or ship's office, wherever it is. And then it can be sent to the head office also through the internet. Good. Benefits of COCOS EDS. Increase reliability because your data available and availability of the diesel engine. Optimize engine performance because you can always balance your engine. Take performance, balance your engine. You are getting the parameter balance engine. Even when engine is running, which a balance engine means reduction in operating costs. Ships operating costs are very high. So whatever percentage you can reduce, there is enough saving. In fact, maybe saving for the whole crew salary, at least for a month or two, or couple of months. It assists for a chief engineer or home office team in decision making because you got the parameters available to you. Prevents failure or reduce risk of failure as it becomes easier to take appropriate corrective action earliest based on the available data and the trends. They can take timely action. If at any time unusual behavior occurs, engine behavior occurs, cause of such behavior is easily known because you have diagnostic tools, you have trends available, you can compare. System also provide for performance analysis and reporting. System also carries out performance analysis and reporting, as I told you, can be sent to the office. Customized report can also be prepared. What all data you need, it will prepare a report accordingly. This is the example of customized report. Here, of course, engine particulars and all, when the performance was taking, etc. When was the last bunker was taken, all these things. What was the RPM the engine was running, and what is the load of the engine, ambient pressure, and fuel index, speed setting. What is the speed setting? Draft condition. All right. Total running hours of the engine, fuel consumption, effective fuel consumption. What is the kilowatt? Then MOP, Pmax maximum, and MOP, P compression. All right. The information is available. Where is the power develop? Power develop. Effective power 9060. Some percentage also is given. Estimated engine load 50%. Normally they say take performance at least MCR, at least 85% MCR, or which is what is your normal running condition. That you must take performance. So here the data which you get is which is readily available to you. Indicated pressure for each unit. Indicated pressure. Very advantageous. Did you ever knew the indicated pressure of your ship? Unless you have taken performance and calculated. Here it is available. Just check it. On PMI computer, it is available. Okay. The Pmax, Pcomp, high load offset, low load offset. I will tell you. This is what I was taking performance. How to adjust this parameter? I will tell you. This is the purpose of this module. And then Pmax offset to balance your engine, to balance the Pmax of different units, or increase the Pmax of all units altogether. Then your Pcomp, P scavenge offset, the value of all unit and different unit. What offset to provide? It is called compression ratio offset also. Pcomp by P scavenge. Remember, P scavenge has to be absolute pressure. Actual scavenge pressure plus atmospheric pressure. Then, of course, exhaust gas temperature and all. All this information is available to you readily. These graphs, trends are available. You can compare with your the performance when you're taking turbocharger speed and what is the percentage kilowatt turbocharger speed and RPM with respect to engine power. This top is the engine power, turbocharger efficiency, maximum pressure Pmax with respect to engine load, the compression pressure, scavenge pressure with respect to engine load. You can take different scales of course for the respective graph. Turbo inlet temperature, exhaust temperature, turbine outlet temperature. So these information are available. It provides easy means of comparing current performance against background curves showing values when the engine was new or when the Coco was installed. Hmm? Online and offline, both modes are available. Online mode. For online mode, the alarm and measuring sensor system are set up with the appropriate control unit and PC connecting during installation. PC connection, because this has to be done in the installation. So all these are fitted already. The data logging facility of the Coco as EDS is then able to continuously take data online from the various sensors. It's continuously data is available. Yeah. Mounted on the engine. Also, same thing can be done for AI also. The data is then processed and stored before undergoing further processing using the monitoring, diagnostic, and train function of the Coco CDS. So once the data is available, the software will calculate various parameters and they will be available to you. This is online method. Module 6, video 2. Module 6, module 2. Offline mode. The system is considered offline if only the alarm system is installed online. Alarm system is online. So alarm is etc. Sensor is fitted and is giving. And the user feeds Cocoa's EDS with additional data which you take. Like individual go and take the performance, which has been measured manually using portable measuring instrument or equipment like temperature and pressure and some more sophisticated electronic instrument. But the PMI box everybody has seen. You can use that. Go to different units, indicator valves, and take the parameters. And then we note down all the other parameters, exhaust temperature, etc. Cocos EDS is also considered offline when online data acquisition is not running for some reason. So suppose online Cocos EDS was installed. For some reason, online data acquisition, the engine which gets the system gets the data, performance, compression, peak pressure, etc., is not available. So it becomes offline. All right. Now, tuning and balancing is what we are interested in. Suggestive sequence which need to be followed for the while balancing the engine. So in this case, various things can be balanced, can be checked and performed, and then balancing can be carried out. That is low load offset, low load offset, high load offset. Okay. Then compression ratio offset or PCOM balance. Hmm. Then mean PCOM, that is average PCOM. The maximum pressure of individual unit and maximum pressure of all units, median Pmax, mean Pmax. So basically, what you do, run the engine at lowest load possible eh, and balance PI load. That means low load offset, indicated pressure, indicated pressure. You know what is indicated pressure? Yes. Then run the engine at highest load possible. Again, take the performance, balance the high load offset. We call it PI, indicated pressure at high load. Then compression ratio offset, each individual unit and mean unit. Then compression pressure, maximum pressure offset or maximum pressure adjustment, balancing or mean pressure, mean maximum pressure. So mean maximum pressure also you can increase or reduce whatever you want. So following these steps will ensure the engine is well balanced. We shall now go to step by step and learn how to change, adjust parameters on MOP as per the performance report. All right. This has to be done on the MOP. Check PI loads, low loads and balance PI low load. So you remember now go to the screen engine process adjustment from the navigation bar. Remember that module 4 MOP screen process adjustment from the navigation bar engine and the tab cylinder load. There will be tab on top. Go to cylinder load because your cylinder load you are balancing. PI is what? PI indicated pressure is the power developed by the individual unit, isn't it? Power developed, all other things remain constant, RPM, etc. The power developed depending on the indicated pressure. Correct? So first, balance the engine at low load. Run the engine at lowest possible load where RPM is stable. Of course, C is calm. Then all these things you have to see. Using the PMI offline program, make a pressure measurement on all cylinders. All cylinder performance is available to you now. In the PMI program now, which I have shown you the parameters list, you will have that list. Check the PI balance of the measurement you have just made. If you have just taken, the performance will be available. I showed you the indicator PI of each unit. Now, some unit will be all are equal. Very good. If you want to increase, you can increase that. If there is a variation between each cylinder, note down which cylinder needs adjustment, increase or decrease of PI. That means that its value is more or less the max is PI value, mean value. There will be some mean value, and the unit which has too much high or too much low. That much we must address. If PI of that particular unit is too much high, we should reduce it. If PI of particular unit is too much low, we should increase it. All right. Remember that offset has to be in percentage. Offset has to be in percentage. Now, let's say these are the value. All right. Number one cylinder 11.8, number two 12.1, 12.1, 12.1, 12.2, 12.1. Mean value is become 12.1. So basically here we see all are basically in the mean values are all within the range. They are exactly at the mean value, but deviation is in number one unit, which is maximum, which is minus 0.3. If you want to adjust it, that means you have to increase PI of number one unit by 0.3 bars. That means you have to increase it. So what becomes the offset? Offset now you need to calculate. So offset become, because this is minus 3 deviation, now you have to increase. So it becomes plus 3. That means plus 3 value you have to input. 0.3 divided by mean value into 100. That becomes the offset value. That you put in the MOP screen. Which screen? I'll just show you. Understood? The mean value deviation with the maximum deviation. Now check that deviation is negative or positive. If it's negative, offset has to be positive. If deviation is positive, offset has to be negative. So that deviation, how much? In this case, we have to increase that much. That it becomes plus 0.3, divide the mean value into 100. That becomes the offset value, 2.4%. Low load offset. So here offset is available minus 5 to plus 5. So in this case, 2.4 or 4%, whatever is come, 2 plus 2.48%, you increase the number one unit. Indicator pressure is balanced. Now you can check again and see if required all are same or require adjustment. Remember that cylinder load and process adjustment. All right. Similar thing, we go run the engine on high load, maximum high load possible, and again note down the parameters and see high offset, high load offset allowed uh, allowed you have allowed minus 10 to plus 10%. Okay, adjustment. Low load only minus 5 to plus 5% is allowed. Let us say this is the value. Whether it is low load, half load, whatever, doesn't matter. Adjustment is same. Suppose this is a high load value. Calculate the offset value required to balance PI and for which cylinder adjustment is required, needed. You calculate. Tell me. Which unit division is more? Maximum deviation? 0.3. Number two unit. Know why to reduce it, isn't it? So it becomes minus 0.3 divided by 13.8 into 100. What is the answer? Tell me the answer. Okay. You can check. So check PI high load and balance PI high load. Procedure exactly same as low load. Hmm. Procedure for balancing PI high load is exactly same as the was done running the engine at low load. Remember the MOP screen, process adjustment from the navigation bar, engine and tab cylinder load. Run the engine at highest load possible, at which engine can be run safely. Using the PMI offline program, make a pressure measurement on all units, all cylinders. In the PMI program, check the PI balance or the measurement you just have made. Note the cylinder which needs adjustment. Last slide I showed you now needs number 2. Please know value of value low or high load offset has to be in percentage. That is important, percentage value. So you have to calculate percentage value. Video 3, module 6. But yeah, okay, we are adjusting PI. But what we are doing to the engine? What is happening? PI actually, the curve, power curve, hmm, elongated. You have seen the power card, no? Okay, start from here, scavenge and goes high and compression cycle. You are actually making fatter or thinner. So that is the average pressure. Hmm. All right, understood? No. Now, why when you are changing the PI, actually what you are doing, you are actually varying the fuel rate. You're increasing or decreasing the amount of fuel. All right. So that's how that power will become more or less delivered by the engine, that particular unit. All right. Interesting. This you can do when the engine is running. So we are actually varying the fuel rack index of the particular cylinder, requiring PI adjustment, increasing or decreasing it. A negative sign will reduce the index, and positive sign will increase the index of the particular unit. Now make a new pressure measurement on all cylinder and verify what you have done is working fine and it is balanced. Readjust if necessary. Simple. Mean of all units can also be increased or decreased. In this case, whatever is the mean value, let's say in this case, mean value is 13.1. Now you want to make 40, for example. So how much you have to increase? 0.9. So what will be the offset? 0.9 divided by 13.1 into 100. That you put in the mean value offset. So all the units will start getting more fuel and more power will develop for the all cylinder. So you must know what you are doing. You cannot overload the engine. You cannot put the offset 10% just like that. So that's why you have to be a good engineer. Understand what is happening to engine, how the engine works, what is the power diagram, what happened to the performance or parameters, what happened to the engine inside the engine, and all these things you are doing. All right. Conventional engine, because you cannot do it, all these things, and you do not do it, so you just come and sign off, but you don't do all these things, isn't it? These are very technical things, and you must remember, use your brain, become a good marine engineer first, then it will be very helpful. The ME engine. All right. This course is also very important. I suggest everybody must do. Even juniors should do it. Once they become senior, they can do it once again. If the maybe few things they did not understand. But when they go on the ship, they will understand. Oh yes, this is what I was thinking. This is what I was told. Now I understand. Okay. What you do now? Check PCOM balance and balance PCOM compression pressure. Again, process adjustment, engine and tap. Now this cues not the cylinder load. You go to the next screen. Cylinder pressure procedure. Using the PMI offline program, make a pressure measurement on all cylinders, see the performance just taken, and check the PCOM. Note the pressure, note the cylinders that require adjustment. How PCOM is adjusted? PCOM is adjusted by what is called compression ratio offset. Some ships you will find it written compression ratio offset. Some some ships written PCOM by P scavenge ratio. So in this screen, I'll show you the screen now. PCOM P scavenge of the cylinder requiring adjustment. Of course, verify by taking the performance again. and adjust if necessary. Now let us say the parameter you have got compression pressure. Average is 17.3, mean is 17.3, 70.3, and the value is 69.6, 70.4, 70.3, 70.4, etc. Now you want that number one unit is PCOM is less. You want this PCOM, number one unit PCOM should go higher. All right. And scratch pressure also you have to note down. Scratch pressure is 1.1. So how to calculate the ratio which need to be put in the MOP? Now, because its value is negative, you have to increase by 0.7 plus. The value become 0.7 divided by scavenge pressure plus absolute pressure, atmospheric pressure 1. Answer is 0.33. That means you have to increase the compression ratio offset by 0.33. It's offset, it's a value, 0.33, not a bar and all, it's a value. All right. Because 0.7 also bar, this is also bar, bar cancel. So this is an absolute, this is a number only without unit. So what this offset does? Tell me. How? Of course, it increases or decreases the peak compression pressure, respective unit. That you know. How does this happen? Pcom by P is Pcom ratio offset value put in the center pressure tab. Closes exhaust valve early or later. So how you are increasing the compression pressure? In this case, the value of 0.33, what will do? It will close the exhaust valve little early. Closing the exhaust valve little early in the cycle, what will happen? The compression pressure will rise. Were you able to even think of adjusting a compression pressure like this, or adjusting your compression exhaust valve closing time? Never. New kind of thinking has to come into the mind of marine engineers. That's why I suggest right from the beginning do this course. Even juniors should, company should send actually. If you need a good engineer, you need to train them. So what is the effect of closing exhaust valve early? But if you close the exhaust valve early, PCOM should rise. If some unit you have to reduce the PCOM compression pressure, what you do? Delay the closing. In this case, value will be offset. The value will be negative. Exhaust will close out later. Again, I'm reminding absolute pressure P scale is to be used by adding atmospheric pressure. Taking atmospheric pressure as 1 bar, value for P scale is 1.1 plus 1, 2.1. Okay. If you have the actual value of atmospheric pressure in the machinery spaces, put that value. All right. Now, actually give you exercise. Calculate compression ratio offset from the following parameters: 128.5, 132.3, 131.4, 132.6, 130.7, 130.6. Okay, okay. So which unit you need to increase or decrease? Hmm? Seems to be number one unit. You have to increase the compression pressure. You can. Now you can calculate. 128.5. So how much is difference? Difference divided by scavenge pressure plus absolute pressure, 1 bar. The value is your value in the compression ratio offset. Okay. In this case also, exhaust valve will close early. All right. Pcom by P is ratio. Okay. Whichever you did. You can increase all exhaust mean value P compression, mean P compression pressure if you want to increase. Okay. The value, if you tell me, I will tell you your answer because we are not doing live course. I can tell you the value what it is, but I don't want to tell you when you're doing the course online. I want you to calculate it. Maybe they write to me. Check mean compression pressure and adjust mean compression pressure and necessary. Why we need to check the mean pressure? Module 6, video 4, I think 4. Why we want to increase or decrease the mean compression pressure? Any idea? Now, if If required, mean compression pressure can be increased or decreased. How do we decide what mean pressure that we need to adjust the mean compression pressure? Each unit we understand balancing, but why increase or decrease compression pressure, which is the mean pressure? See, cylinder pressure rise, that is the difference of P max, maximum pressure, peak pressure, and the compression pressure has to be within certain range. This affects the mechanical. If the too much difference, it brings the mechanical stresses on the various components of the engine. All right, tie rods, bearing, other things, back plates, etc. So engine maker says keep this within certain range. That range is given. You can ask your technical department to get you the details. What should be the difference? On an average, higher the load, lesser should be the difference between Pmax minus Pcom. So normally it is around 15 bar of these engines. Because actually they are same as SMC engine, conventional engine. Conventional engine also you have to keep same pressure difference, but their adjustment becomes too difficult, isn't it? Compression pressure you cannot adjust. So at 75% load, difference can be 29 bar. 50% load, it can be 34 bar. At 25%, again it becomes lesser. It should be more than 25 bar. But also note down that 1 bar increase in average Pmax leads to 0.2 to 0.3 gram per kilowatt hour decrease in fuel consumption. Specific fuel consumption reduces. Okay, so it's in your interest to use as high as peak pressure as possible. To keep the difference within the permissible limit of 15 or 29 or 34 or 25, but what you do? Increase the PCOM. That is the advantage of increasing the PCOM here. All right, understood? Any questions? Well, very good. If the mean PCOM is 70 bar and the sky pressure is 1.1 bar, we need to increase mean PCOM by 2 bar. Value offset become 2 by 1.1 plus 1 atmospheric pressure, 0.95. Increase the value by 0.95. All the units will close, exhaust valve will close literally, and all the mean peak compression pressure will rise. All right. If you require, then you do it. Calculate mean PCOM by P-scaven ratio offset value required to increase mean PCOM by 2 bar. If mean compression pressure is the 131 bar and scaven pressure is 1.87. All right, your answer. Okay. Brain is something you more you use, more you get. You have to spend it. It's not money, don't hold it. More you use the brain, more you will get it. All right. Pmax balance. Of course, run the engine, check the parameters. Pmax different between two cylinders, individual cylinder in a unit, whether 6, 7, 7, 8, whatever unit. It normally recommended to be 3 bar. How much in your company recommends? 3 bar. Some maybe depend your company, but as per my, it should not be more than 3 bar, plus minus 3 between two units. It is advisable to keep Pmax difference between any two cylinder not more than 3 bar. Pmax offset value is directly entered. In value is in kg per centimeter square. How many bar? You want to increase number 2 unit by 3 bar? Just increase by 3 bar straight away. So plus minus 20 bar deviation is allowed. You can change, increase and decrease value by 20 bar or minus 20, reduce by minus 20 bar. It's very simple, straight away. Go to MOP screen, just change. So simple. Let's say these are the Pmax. 125, 120, 134, 127, 126, and 127. See that unit 3 maximum is 134. And the maximum difference between unit 1 and 3 is 9 bar. We can reduce the Pmax of unit 3 by 6 bar and check it again. Isn't it? Because roughly This you can do. Let us say the new value when performance taken become 126, 128, 127, 127. If it's now balance, don't do nothing. If it's still in balance, change again. You want to increase the P max for all units, straight go to P max, mean value, increase. Straight away, simple. Just put the value by how many bars you want to increase. Check now mean P max and adjust mean P max. So why is necessary? Once I told you, because increase in 1 bar of P max reduces the fuel consumption, specific fuel consumption decrease by 0.2 to 0.3. Therefore, increase in P mean value of P max shall increase fuel efficiency. Number two, if difference between P max minus P com is excessive, mean mean P max may be required to be reduced. If you already increase the P max P com as possible, ideally effort should be made to increase the P max. But if we not, you can reduce also. Adjusting Pmax is simply done by putting the required value in mean Pmax in bars, plus minus 20 bar range is available. Increasing, actually it means when you increase the Pmax, what you are doing? Advancing the timing, injection timing. Something like VIT, what you used to do in conventional engine, same it is doing here. So how does the Pmax of the individual cylinder increases? Putting the value of required value increase or decrease of Pmax, we are actually advancing or retarding the injection timing, depending what you increasing or decreasing the value of the Pmax. All right. So how does the Pmax of the individual cylinder increases? By putting the value of the required value to increase or decrease of Pmax, we are effectively advancing or retarding timing of the injection of particular unit. All right. Any questions?